Hello, everyone, and thank you for coming to our webinar called A New Approach to Big Data Analytics, and how you can centralize all your telemetry, all of your logs in your cloud object storage and analyze it with ChaosSearch so you can unleash your insights today. My name is Rocha, and I'm the Vice President of Product and Operations at ChaosSearch, and I'll be walking you through a presentation and a demo of our product today, along the lines of what we did at AWS reInvent a couple of weeks ago. We are the first Search+SQL analytical database built for chaos scale. What that means is that we have done the hard work and hard tech to make cloud object storage performant, so you can leverage the cheapest, most scalable data service in the cloud, Amazon S3, Google GCS, Azure Blob. And we've made it performant so you can use it as a live analytics database. With that, you can centralize all your streams. That is where the vast majority of all this data is being generated today. And you can analyze them for both operational and business use cases, unleashing their value to the organization. With that, you're able to have fast time to access and insight, massively reducing the time, cost, and complexity and risk of existing solutions. You can see here some of our customers, from Equifax and Blackboard to Klarna, who have two things in common. They have massive data being generated at scale, and they like the ability to keep data all on their side because they live in regulated environments where data governance is key. So why are we here? We're here because data keeps growing. Today, most of that growth comes from a specific type of data, from telemetry, machine-generated data that is being created from different applications and the underlying microservices that have been moved to the cloud, and since then have been generating ever-increasing amounts of data, and that have specific characteristics. They keep changing over time, they're different to one another, and so as data volume, velocity, and variety increases, current tools that were built for a more structured type of data and a more batch type of environment have struggled with one of three things. They either become too complex to manage, non-performance, or too expensive to scale. And what ends up happening is that companies do not analyze all the data that they generate, creating a loss of insights that leads to loss of visibility and on the operational side, but also lack of ability to be data-driven on the business side. We're here to solve that. So you can simply stream all your raw data into your cloud object storage and get insights out seamlessly. With us, all you have to do is land your data into your cloud object storage, give us read-only access to that data. We're going to read that data, transform it into our data representation, store it back onto your cloud object storage in a new bucket that you provide us, and then we're going to manage the compute. So you can analyze it via open APIs like the Elasticsearch API and SQL API in the Trino dialect, and cloud-native visualization tools like OpenSearch dashboards and Superset, which we have embedded in our console, and that I'll show you in a little bit. And also, you can connect out to tools like Grafana via the Elasticsearch API or Looker, so you can also keep your preferred tool of choice. At a high level, this graph kind of shows how the data flow goes. You stream your data into cloud object storage. We manage the compute, so you can then can analyze it via these open APIs and common visualization tools. And what that enables is three key use cases. Best of breed observability, so you can complement your monitoring tools used by your developers and your SREs with a platform that was built for chaos scale, so that you can have unlimited retention at a fraction of the cost and have true visibility onto your microservices architectures. You can activate your security data lake and complement your security tools, so you can face advanced persistent threats in an ever more complex security environment. And you can also unleash the value of this telemetry, this product data, so you can be more data-driven on the business side. So all you have to do again is stream your data into cloud object storage and give us a couple of queues, either SQS in Amazon or PubSub in GCP. Then you need to connect to us. Read-only access to the raw data, read-write access to a new bucket that you provide for us, so that all data at rest stays on your cloud storage. Then you need to create a couple of artifacts, object groups, and views, which I'll show you on the demo. And finally, you can analyze it via these open APIs and cloud native tools, Elasticsearch and SQL API, OpenSearch dashboards, and Superset. So you can meet these use cases. At a high level, it's a unique cost performance in the market where you have minute ingest latency and second query resolution times at scale, which are typically meet the requirements of analytics use cases. You can have the cost of cloud object storage, which typically leads to 50 to 80% savings and the unlimited retention that you get from the fact that we separate storage from compute. We're built with flexibility in mind, so you can ingest these streams that change over time and that have a tricky schema. We automatically detect schema and dynamically map it, so data is available to analyze as soon as it's ingested. And we're enterprise grade. We're built so that all data stays in your cloud object storage, fulfilling a lot of data governance needs. Then we integrate directly with your SSO, so you can keep managing access wherever you manage it today. And we have granular RBAC in our platform, so you can meet and have full visibility on your access requirements. And finally, the best of the resilience of the cloud, the durability of S3 with its 11 nines or GCS, and the availability of EC2 with its 4 nines of availability. And this is why customers like Equifax use us. Because with us, they can centralize all this data across their different teams and use cases without having a high burden to manage the tool and the pipeline associated. As you can see here on the quote, with ChaosSearch, we no longer have to move or transform our data, as Jeff Kincher, SVP of Engineering Services and SRE at Equifax said. That means that they don't have to think about it. The data is just there for them to pair. It's this ability to not have trade-offs between what data you can analyze and cost that allows companies to truly be data-driven and centralize the data that they want. And break these silos, as in this second part of the quote. Instead of taking a piecemeal approach with multiple silos and different applications and different databases, they can now have a live analytics database straight in their cloud object storage that can serve as a single pane of glass in a way to standardize the MO across these different business units so that they can be truly data-driven and have observability at scale. So as we started with an Elasticsearch API and Kibana, we could be thought of as an ELK replacement for log analytics at scale. And what we would provide there is basically the same tools, but none of the pain, because there's no Elasticsearch under the hood. Elasticsearch is a great database. It is fast at small scale. As you scale, you typically have two key problems. You have a trade-off between retention and cost. Because as data grows, you need to have a certain set of data nodes with a certain amount of memory. And so as you grow, either because your ingestion grows or your retention grows, you need to have more and more data nodes, ballooning the hot storage costs. Right? On the other hand, you have a manageability problem. As these clusters grow, you need to define shards, to think about cluster planning, to think about what type of data nodes you have and how many. And this becomes even more problematic in spiky environments like log analytics, because if you don't plan ahead well for the amount of storage and capacity that you need, your data node can fall over. You can lose data. The system can be unavailable. And so you need to build all these DR pipelines to make up for that. So at scale, this becomes a big challenging problem. With us, all this becomes easier. You just have to land your data into cloud object storage, and that's that. You can keep the same Elasticsearch API, you can still use OpenSearch dashboards in our console, which is just like Kibana, and you can have unlimited retention with significant savings and in a managed service that is truly managed, does not have durability and finicky issues at scale because it has the durability of S3 and higher. And that is what happened with Blackboard. They, after moving to us, they were able to lift 90% of all the operational burdens. So they could focus more on keeping their production environments up and troubleshooting them rather than managing their log analytics tool. And because of that, we can be used as part of the broader observability initiative to complement tools that have a complementary approach to it. Most observability tools that are in the market focus primarily on monitoring. How do I monitor my system health so that I know when there's a problem? To do that, I need to be able to build dashboards and send alerts based on metrics, primarily, so I can know when something is off as it happens. However, these solutions at scale balloon their cost, primarily because architectures are becoming more fragmented due to the emergence of microservices. They generate primarily more logs. And in logs, you're charged by the amount of data that you ingest. Right? As an example, a tool like Datadog charges $2.50 per gigabyte ingested for 30 days retention. With us, we start at 80 cents per gigabyte and provide unlimited retention so that you don't have to have this retention cost trade-off. And what you can do is complement the two tools. Either reduce the amount of retention in Datadog, making it much cheaper to ingest all the same logs, or just do log analytics in us and complement the tools like Datadog for monitoring. What that allows you is to have the best of two worlds. Keep the monitoring tool that you have so you can detect issues as they arise, but use us as the repository, the operational data lake for analytics at scale, so you can troubleshoot using all the data that your systems generate without retention limit at a fraction of the cost, and can actually have observability in today's microservice architecture. An alternative approach to this is the approach that was created by Grafana. So Grafana created a single UI so you can analyze all these different telemetry, but allows you to connect to different data sources under the hood. What that allows you is to have a different database for metrics, traces, and logs that can be promoted by Grafana or can be provided by any other vendor. You can keep using Prometheus for metrics and Tempo or another trace analytics tools for traces, but then use us for the logs. So you can still have a single pane of glass for your observability within Grafana, but you can both have the benefits that we provide versus all the other tools, the cost performance at scale without the retention limits, but also enhance Grafana with log analytics. Grafana is great for on the log side. Grafana allows you to filter the logs for a specific time frame and specific metadata. But if you want to do deeper analytics within Grafana, it is limited in its ability to do that. By using our console, you can not only extend that functionality with what's provided by OpenSearch dashboards, but with our SQL Access, you can also enhance the type of constituencies that can leverage that data by providing SQL access to the same data. So best of breed database approach for superior cost performance, a single UI so that the users don't have to jump around tools for a specific task, enhanced by the Chaos Console that enhances the type of tasks that you can do. But this type of telemetry doesn't just have value for SREs and developers that deal with observability. It also has value for security use cases. It's the same type of data. And the approach is also similar. You can complement your security tools, be it the XDR or EDR, the SIEMs or the SOARs, which are typically used for detection of potential threats, management of incidents, and acting on your environment to fix any issues, and complement that with a database that was built for analytics at scale. So you can unify all your telemetry without retention limits at a fraction of the cost, and face the advanced persistent threats that pervade today's security environment, and help you basically be more proactive in your security approach so you can better protect the current complex enterprise environments that we live in. And finally, all this same data also has business value. Telemetry holds product data information. Today, we have the emergence of the digitalization of the economy. And what that means is that every company is a software company. What that means is that product data is generated via telemetry and keeps growing. That product data today is mostly locked in IT because it's thought of as operational data. And because of that, it's not typically accessible by the business side of the house. It is also generated in a stream fashion. It's much more frequent, this generation. And because of that, the whole idea of batch uploading data with a strict schema doesn't really fit the model of telemetry. And finally, we have the emergence of SaaS across different departments. You have CRMs, you have MarTech, you have product management tools, and all of them are great to manage the workflow within each department. But they lack visibility across departments. And users are unique but do activities across all of these. Because of that, there's the need for a database approach to complement all these different applications. All these different macro trends is the reason why we have the emergence of fresh data lakes as a way to create an analytics database that is live, that can provide data in real time as it happens. And so you can have a better understanding of users as it's being generated. And this unlocks many different use cases, from the product side of the house with the ability to do better experimentation for growth or better product analytics to understand how users use the different features in your product, to marketing analytics, where you can leverage the product usage data to better understand how to target new customers that have the same characteristics and new users that have the same characteristics. And for customer experience, because the products are now digital, this telemetry holds all the information about how users use your product. And they are a leading indicator over whether a customer or a user will keep using your product, will monetize, or will refer your product to users like that. Because of that, we allow you to create a live data lake for real-time analytics that unleashes the value of this product data so you can be truly data-driven. Finally, we provide a way to bridge operational and business analytics because we are built to handle data at scale that holds both operational and business value. We allow you to centralize all this raw machine-generated data and complement the tools that you already have, from observability and security, where most tools are built for detection. And our ability to centralize this data at scale over longer periods of time can help you troubleshoot and seamlessly complement the security and observability applications functionality. And also on the business side, where we complement the focused approach of SaaS application and also the batch approach of cloud data warehouses and data lake houses, so that you can have a live analytics database of all your product data and unleash its value across the organization. And with that, I'll show you a demo of what it actually looks like. So first off, it all starts with some prerequisites, the most fun part of the demo. Get up and running, as I said earlier in the presentation, you need three things. You need cloud storage buckets. So I'm going to use AWS parlance. You need S3 buckets, raw data buckets where you land raw data, a new bucket that you create for us. You need the right IAM policies, read-only access to the raw data, read-write access to the new bucket that you create for us. And you need the creation of queues for live ingestion. SQ, so that as new data lands into your raw data buckets, it gets pulled to the queue, we get notified, we read it, transform it, and store it back on your read-write bucket that we then use to analyze that data. All these prerequisites are documented in our website, and we have CloudFormation and Terraform templates to help build those. After you create them, this is what our platform looks like. If you were to check out our platform, we basically bring up a cluster with our compute. You would come here, you would connect the role arm created by the creation of those resources and policies on your AWS console to our cluster so that our compute can talk with your storage. And after that, you can use our platform, right? This is what the platform looks like. It has 4-ish parts of the platform. Storage, groups, and views are setup and management parts of the platform. Search analytics is today Kibana 7.10, and we're moving to open search dashboards. And SQL Analytics is superset. And you can probably show it to you. So this is Kibana 710. And this is superset. Kibana 710 and superset is how most of the users can leverage our platform. They can also use it via API, as I said before, or connect out to other tools. Now, it all starts in the storage. In here, you can see all the different S3 buckets that this cluster has read-only access to. And these groups are what we call object groups. You need to define those when you start with the platform. An object group is basically a filter onto your S3 bucket. So you have here an S3 bucket with a bunch of different folders, subfolders, and files. You can set up a prefix to say, okay, this is a folder that has all the files that I want to ingest, for example, in ELB logs. After that, you click Next, and we automatically detect the file format. These are the ones we support: CSV, logs, JSON. Unknown are like text files, and we're now working on support for Parquet. If they're compressed or not, and for common log files or self-describing formats like JSON, we automatically detect the parser, and you can tweak it here if you'd like. Then after that, you can validate if the parser is parsing correctly the file. And then an object group kind of has three things: a name. If it was live, you can set up here the SQS role ARN so that we can get notified as new files land based on that prefix. And then a retention policy. The retention policy is part of that of the value proposition, which is you can set it for days, months, or you can uncheck it and keep it forever. Okay? So once you create the object group, you can start indexing. And as you see here, you have here some information about the object group: the name, the bucket, when it was created, the file format, and then you'll see here that it has started to ingest some of the different records as it comes through. And you can also see here the retention policy, so that you have a single place where you can manage all the different information. Then after that, you can see here all the different schema, and this was, as you saw, detected automatically without requiring the strict definition of what it was. And this is dynamic, so that if your logs change because it's an application log and someone decided to log a new field, or if schema evolves, by design, we let it evolve over time. And we also give you the flexibility to enforce schema as it comes. You also have the ability to define some optimizations like exact match and tokenization, like you would in Elasticsearch for so to optimize the performance on some of the queries, or the ability to mask certain fields. Then after you create an object group, you have the ability to create views. Views are basically an abstraction so that they allow you to set up your pipeline and your object groups that are physical, that generate physical files that get stored in your read-write bucket. From what are views that are how the users want to analyze it. So you can put different object groups together or separate an object group out into multiple views to isolate access across it. The former would be, imagine you have different types of logs that you want to put together in a single admin view and create multiple object groups in a single view. Or alternative, imagine you have an application logs from multiple the types of customers that all have the same schema, but then you want to isolate across each of your customers. You can also do that. So let's pick just the object group that we just created. After that, in the view, you can create some refinements. So imagine you have a field, you have an IP field, and you want to parse between the main IP and the port because that's how this team wants to analyze it. You can do that. You have the ability to materialize a field with JSON path. Imagine if you had a nested array that you wanted to analyze, we have the ability to support nested array queries and a bunch of other virtual type of transformations that you can do here, so that users have the ability to tweak how the schema is according to their use case without changing the pipeline. And after that, you give it a timestamp, and you give it a name, and that's it. This view is going to be interpreted by Kibana or open source dashboards as an index pattern and by a SQL visualization tool as a table so that you can query. So you can come here and do a log view and search it over the last 5 years. This is demo data. And this will work as Kibana, right? So you can use this to then troubleshoot and do all the classic things that you can do in Kibana. So this is the Discover pane that you usually use for troubleshooting, where you can basically filter out some specific things. You can look for specific tokens so that Cipher. So you can do this type of filtering and wildcard search type of queries, so you can narrow it down and you can troubleshoot for a specific problem and identify which host, what was the actual type of message that were being issued that were creating the problem. And then you can also create visualizations that you can put into dashboards so you can monitor infrastructure. So imagine the LB logs we just created. This is just a set of different visualizations created with the same type of data. So you can monitor like status quotes, the type of how much information is being received, and different types of methods and stuff like that, right? But then this is all the operational type of use case. So you can use this to provide the best of observability by creating a complementary log analytics solution to your metric solution. You can also, for SQL type of use cases, you can also create, unleash the value of this data for business purpose, or even for operational use cases. If you want to correlate two different type of data sources with different information, you can uniquely do this with our platform that you typically cannot with operational monitoring type of tools like Elasticsearch, because they do not have relational join support. So imagine here in this use case, you have the same view that we created. And we also have a table that maps from IP to location so that you can do stuff like, I want to know where does my traffic kind of come from over the last time that you want. So you can go from IP to location. So what you can do here is imagine you have those two views and you want to correlate them and do a join so that you can see, okay, this comes from Ashburn in this state and all that. And you can see where the traffic, the count comes from geographically rather than by IP, right? Then after that, you can save this as a new view and then you can use it to create visualizations on top of it. So you can create dashboards on top of that view so that if that it changes over time, you can use it as a view virtually, right? So if you can come here, imagine you want to create a new chart, pie chart that leverages that data set. You can do that. Imagine you want to know what that is in a pie chart that tells me count where the top 100 locations where my traffic is coming from. You can see that here, and then you can play with this like you would normally. But if you want to see what's the top 10 places where this comes from and where my traffic comes from, you can also do that. And so what this allows you to do is, again, ingest data once in your object groups, create multiple views for the different type of use cases with the ability to do some virtual aggregations and transformations so that the views are aligned with the end user's use case, and then unleash access to that data via both search analytics for operational use cases like observability and security data lakes, and also SQL analytics, either for operational use cases or for business use cases. So we can unleash the value of this data on the business side. So imagine if this telemetry were application logs and you were correlating it with a user table, you could see what is the usage from my users and how does it evolve over time, right? And that is the power of having a Search SQL database that was built for ChaosScale. Unlimited retention, a fraction of the cost, access where you want it. And with that, do you have any questions?